Yes, thank you very much for the invitation. Now, we are a small and medium enterprise from Germany. We work on many areas, but one is biocorrosion and anti-fouling, so this is a little bit what we did. So we thought about how to absorb the lithium out of the brine, and the idea was to use gram-positive bacteria. Gram-positive bacteria have taconic acids, as you can see on the picture here, in their cell wall. So and the advantage of those bacteria is that they're quite fast growing and can be also integrated in a continuous process for direct biosorption of lithium. Of course, the disadvantage is that the lithium is then complexed in the biomass and needs to be extracted subsequently. So the basic idea is from the literature, so it was about 20 years ago already described. We used different gram-positive test organisms like Bacillus subtilis, Christina megatherium, and Glutibacter. In the first step, we used lithium chloride in sterilized water, so not real brine or synthetic brine, but only lithium solved in water. And then we did this biosorption experiment, and as you can see, this was quite close to the data that from literature, but we had a little bit higher absorption than based on the literature. And then and on this slide you can see the comparison between the different organisms that we used based on different concentrations of lithium in the liquid, so in the water. So 50 compared to 150 milligram in the three different organisms that we used. And basically the results show that Bacillus was the most efficient to absorb the lithium from the liquid here. And of course then the subsequent question is, what if now you have Bacillus bacteria with lithium, and then you need to remove the lithium somehow from the biomass, and we did that with the aqua regia digestion, so filter the organisms, the biomass from the water, and then aqua regia did digestion, and this worked quite well, so we have almost 100% recovery from the biomass then subsequently. Yes. And then the next step was to use real brine, and we used the low salinity brine from Cornish lithium from Cornwall, and with a lithium content of about 6.6 milligram per liter. And as you can see here, the biosorption was significantly lower, and we think that was due to the high salinity of the brine. So we diluted it by 1/10 to get more growth of the bacteria, and as you can see here, these are quite nice growth curves of the bacteria. So if you reduce the salinity of the brine, then the growth is enhanced, and you have a good growth of the organisms then subsequently. So that was one. So then we upscaled the process. So the experiments that I've shown so far was in a batch, but of course the idea is to have it in a flow-through reactor, to have the option of a continuous flow-through process. And you see the experimental setup here. So the brine is coming into the reactor where you have the bacterial culture, and you will have to feed nutrient solution, of course, here to make the bacteria grow. And in that setup, we also had here, it's a little bit larger, some discs of polycarbonate in this example, to have a surface where the bacteria can grow biofilm on. Normally, when you have a biofilm, so a larger layers of organisms on a surface, then they might be more efficient to absorb the lithium. So the idea was to see the absorption in the planktonic cells, but also on biofilm cells on both surfaces. So, and then at the end, of course, you get the cell-bound lithium in a collecting vessel. So that's a little bit the flow-through process that we used here. We used Bacillus subtilis as it was most efficient. We used a quite low temperature here, which was 80 degrees, so room temperature more or less. We used, as I said, in this case we used the artificial low salinity fluid for the experiment, and we had to do ventilation. Of course, these are aerobic organisms, so they need the oxygen to grow as well, not only nutrition. And then we did filtration, and again, aquaregia digestion of the filter cake to find out with ICPOS how much lithium we were able to soak. And here you see the results of those bioreactor tests. We were able to have a quite stable and maximum cell count of approximately 10 to the 9 cells per milliliter over a 3 weeks experiment, and a constant, as you can see here in orange, continuous yield of lithium. The lithium yield in this reactor was approximately 8.6 milligram per day. So that would be per year, then 3 gram per 350 milliliter. That was the volume of this reactor, as mentioned before. So higher fills, to our experience, are impossible because then the lithium is limiting here, and the cell density is difficult to get higher than this 10 to the 9 per milliliter that we got here. On the lower chart, you can see the sorption by biofilm cells. So that was also successful. As expected, the biofilm cells were also able to yield lithium from the brine. So that was and was depending on the surface available surface area of the biofilm as also expected. So to summarize that, we were able to establish a continuous biosorption process with Bacillus subtilis, which is a non-pathogenic BSR1 gram-positive standard soil organism. So it's a standard organism from the normal soil. It can form endospores, which might be helpful because in endospore form they are very stable. They can be active or activated over many years, so easy to transport as well. The Cornwall brine is inhibiting the microbiological growth, so we would need to dilute it 1/10. However, the artificial brine with comparable soil contents did not inhibit, so that was a little bit inconclusive data, so maybe we need to put some more work into that. The upscaling process here with the bioreactor was also successful, so we think a pilot scale could be technically feasible, and we think with a low salt content brine, we can, with approximately 6.6 milliliters lithium per liter, we could almost completely extract that by this culture experiment, so that was quite good. If this process is too expensive and feasible in the practice, that's a question. I would say it's a proof of concept, so it may work. Maybe needs a new project to work on that to make it really economically and technically feasible in the practice. Thank you very much.